So in contrast to network optimization, simulation is not an analytical method for optimizing the supply chain. Here the time is relevant. The experiment used to properly configure inventory policies. So simulation experiments are used to properly configure inventory policies or find optimal product stock volume. It might eliminate the possibility of lost orders and execute what-if scenarios to see how the changes you make affect the outcome. The simulation experiments allows us to find the exact quantity of products available in stock. It allows us to observe the actual products delivery on the GIS map, and it allows us to gather data for detailed statistics generated in real time. So we will further add the data that is required to run the what-if scenarios for simulation. We already have data related to sourcing of products, inventory policies, and expenses incurred. I will convert this into a simulation experiment. So the aim of this experiment is to model the actual product delivery on the GIS map with the detailed statistics generated in real time. It is used as well for what-if scenarios to see how the changes you make affect the outcome. So after receiving the first simulation results, we can run further simulation experiments to test whether it is the different what-if scenarios in search of the best balance between inventory volume and service level quality. Simulation experiment requires properly configured sourcing and inventory policies. In this phase, we will create and define sourcing policy. The sourcing policy will be used to define the products to ship their sources and destinations. The inventory policy is used to optimize the amount of products to keep at a particular DC. It must be the least amount covering the incoming orders. Now, prior to creating the policies and the sourcing and inventory policy, we will create a group of distribution centers. This will help to simplify the process of defining inventory and sourcing policies, as well as defining them for the whole group, rather than defining the inventory policy for defining the policy for each of the distribution centers individually. So let us create a group of distribution centers. So what we will do is we will navigate to the groups table, and then we will see that there are certain groups that are already created from our imported network optimization experiment. So we will create a new group of DCs, and we will name this group as DCs. Now we will need to define which are the DCs. So we will click on sites column, and then we would identify which DCs we want to group it. So we will identify the ones that are suggested by our experiment. Now we can move to define the sourcing and inventory policies. So we'll first define the sourcing policy. So we'll navigate to the sourcing table. It already contains a lot of policies which were created automatically based on the product flow table records that we defined in the network optimization experiment. The sources column contains DCs, which will be servicing customers that are defined in the delivery destination groups. The content of the group can be seen in the groups table. In other words, the sourcing policy is already created and defined for customers and DCs. We'll now substitute the existing policies with two records, which will allow us to have just two policies, one for DCs and one for customers. So we'll add two records, and then we will set the products to the one that we are working. So this order we will serve for the customers, and the ones that we created, and the next one we will serve as DCs. In the sources, we'll set to DCs for the customers, so that it means that all the customers are served from the DCs, and for the DCs, we will set to the port of LA from where the DCs are being served. Now we will, what we need to do is that since we have already defined the sourcing policies for our new groups that are created, we will exclude the other policies that got created automatically. So we have completed the defining the sourcing policy. Now let us define the inventory policy. So now we will go to inventory table. It already contains policies which were created from the previous experiments. So now we will not be using them since we have created a group of DCs that contains all the DCs we need. So we will navigate to the inclusion type and we will exclude one. Now we will click on add. And we'll specify that parameters for the inventory policy. So we will click on all sites and then we'll select the DCs. So we are defining the inventory policies for the DCs. And then we set the product. So this means distribution centers will purchase the consoles of the product using a min-max inventory policy. And that is we can set it over here. And then the minimum we can set to like 300 and then maximum we can set to 3000. And we can consider that there were 1000 pieces in the initial stock. So now we can run the simulation experiment. Okay, so what this means is that when we set the simulation experiment, we need to change the product statistics units to pieces. And then we can configure the statistics as well. So what we can, this gives the ones that we want to specify. So we can select everything and then toggle between, so we disable everything and then we would want to see the statistics related to total cost. We toggle it, and then we might want to see the available inventory. We might want to see the demand, the dropped orders, so demand dropped orders. We can click on OK. And now we run the experiment. So in the GIS map, it is allowing us to observe the real-time simulation with shipments which are found in the purple dots. So the items are shipped from distribution centers to the customers and from the suppliers to the distribution centers. So our next step would be to add the statistics that we would want to compare. It can be done in the dashboard. So this dashboard, we can add particular statistics. We can click here and then click on add item. And then we would want to see probably total cost. Then select it. We would want to view it as a table. Click on OK. And then we would want to see the available inventory. So we click on it. And we would want to see it as a line. Click on OK. Now, the third thing we would need to add statistics is for the demand received at the DCs in terms of the lost orders. So how many orders that we lost at the DCs. So similar to the previous two items, I will select this only on the changes that I would want to see the number of orders that are dropped by each of the DC locations. So I just do the by object, by item. So we see that we are seeing over here that there are some orders that are lost at each of the DCs, and that number is we can change the number at runtime as the simulation is going on. Now we can maximize the speed, or we can alter the speed of the simulation, and we see that the simulation, the statistics are changing. So if we want to, see the available inventory at any point of time, we can just increase and then we can see the horizontal zoom for a particular period, zoom in on the particular period, and we can see how the on-hand inventory looks like for a certain over a time period. What we will do is that we will increase the speed to maximum speed. And then once we see that it has finished, we'll click on this and then want to save the result. Yes. So we see that the 6 orders were lost at the Elko DC, the 72 orders were lost at the Vicksburg DC, and 316 orders were lost in the Wilkes Barre DC. The total cost, we see that the total expenses of the placing the orders, the transportation cost, the outgoing shipment cost, and then the opening of the facilities. Now, probably we would want to add a new page where we would want to see the total cost by each location. So then what we do is like we increase this and then we select the object as per item so that we see the total cost at each location. And then we can see the demand received or dropped orders as a total value against which what we did is like we did it for each individual locations, and then also we can see the on an inventory available inventory per item allocation. So we would want to change the type as chart type as a line. Let's analyze the data. So if we want to see the number of dropped orders, so we would want to see it at the daily level maybe. So we can see toggle to daily and demand received the dropped orders at a daily level. So we would want to see it at a per item level. So at each location, how many of the dropped orders are dropped. And then we would want to select the available inventory on a daily basis as well, and we would want to see for a particular location region how the on an inventory is looking. So we see that there are a few orders that are lost on the on a particular day. Now we see that the dropped orders on a particular day and or a time period, a particular time period, how many orders are dropped, and see that we can see that there are 2 orders that are dropped on the 4th day. This means that the initial amount was not sufficient. We can run a number of what if scenario to adjust the inventory policies and examine the difference that the numerous results will give us. Now, if we want to run a what if scenario, so what we can do is we can go to the inventory table and we can change the min max values to a higher value. So we can say that okay, it's 2,000 to 5,000. So and then the initial stock maybe we can say set it at 2,000 or maybe 1,500. Then we can see go to the simulation experiment and run it. Now we can run it at a maximum speed and see the effect. So we see that we have not lost any orders doing so. I'll just stop it and save it. So if we compare the result obtained from statistics 2 and statistics 1 by changing the min max amount and the initial stock, we see that we have lost few orders in the initial experiment, whereas there is no loss in the second experiment, but the total cost has increased in the second experiment. So in the first experiment, as you see, the total cost was less. So it's a decision that we need to think of whether we would want to allow the lost orders or we would want to allow the total cost to go high. So we have successfully completed the simulation experiment, and next we will see an experiment that considers the production policies. So now what we will want to see is that to extend the existing supply chain production logic, we will examine the production peculiarities that will help us better to understand how it works. The supply chain will comprise of 2 distribution centers that provide plastic food storage containers and cake molds to 20 customers in the largest cities of United Kingdom. So to add a production logic, we of course would need to create a factory. We need to define raw materials, define bill of materials, define production policy, add suppliers to the raw materials, adjust the sourcing and inventory policies. So what we will do is that we will import a scenario, add a factory. We will define the factory's location and update the inventory and sourcing policies. So we would be having the customer data, the product data, the demand data, distributions center located in an optimal place, the inventory data, and then the sourcing paths that would be properly configured. So let's import a scenario. We'll see the network. So 20 customers in the UK are supplied with food storage containers and cake molds by the 2 distribution centers located at Oxford and Manchester. So we will run the simulation experiment and observe the results. So we are taken to the simulation experiment view, and we see that the configurations are there already. So we will run this experiment in virtual mode so that maximum speed. So it shows experiment is completed, so we will stop it and save it. So we'll see the profit that is obtained and then the demand placed by customers at each of the district locations. So we observe that the current status of the supply chain is that this profit made and then the total demand placed by the customers to each of these locations. Now what we will do is for production, we will add a factory to the supply chain. So what we will do is we will go to data and then open DCs and factories table and click on add, and then we will name it as factory. And then so we will select the type of the factory as factory. So it will get updated as factory location. And then we will open the locations table. And we will define that in which city we would want to place this factory. So what we would do is like here for is a city which we will name it, and then it is of course in the UK. So we will say that in the UK, and then we will say autofill coordinates so that it automatically fills the coordinates of the location. So we now need to properly define the product flow. So we will first start with inventory policy. We'll start adjust the inventory policy, and we will double click on the all sites here in the inventory table. And then we have also just created the sites group, which contains the two DCs. So we will change the policy type to min-max policy, and then we will set the parameters as 45,000 and 145,000. Now we have defined the inventory policy. Now we will create the inventory policy for the factory. So what we will do is we will set it as unlimited inventory because we don't want any limitations on the factory. So now we will define the sourcing policy. So what we will do is we'll go to sourcing table, and then we will click on add to click. We'll click on double click on sources, and we will click on sites. So this will signify that all the customers are being served from all the sites. Now we will click on an add button and then set the delivery destination to sites. And then we'll click on the sources to factory. So that means that all the sites are serving to the customers, and then the sites are getting from the factory. So we have introduced the factory and then defined the inventory and sourcing policies. So now we will run the experiment. So we will add the statistics related to demand placed and the available inventory at each of the DCs. So the order placed by site and the each of the DCs, and then the available inventory. So what we can do is we can click on a new page, and then we click on add item, and then we expand the orders, and then demand placed orders by site. And then we go to object, and then we select the two locations. We don't select the factory because that's what we don't want to see. And then in the toggle for per item, we would say that, okay, so we'll say it as a per item basis. So for each location we want to see. And then in the same way, we would add the available inventory from the product section. So what we would do is we go to products and then see the available inventory. And then we will see, let's say that, okay, we want to see only those two DCs, and then per item basis. We would not want to see a line chart for this. And then we would select daily, so we would want to see it as a daily data. We will select it, and then we will do it at the maximum speed. Now we'll stop it, accept the result. So we see that in the first step we have completed that we have imported a scenario, added a factory, and defined the sourcing policies to it. Now we will create another scenario where we will define the product and just the inventory policy of the factory, and then define the production policy. So we will now define the production logic. So what we do is we go to the data, And then we go to the inventory table. And so we set the policy type for the factory to min-max policy. And then we will set that policy to 45,000 to 145,000. Now we'll define a production policy. So what we can do is like we can search for the production table or we can type it here. So we go to the table and then we have to add. So click the side cell and choose factory and then double click the product and then food storage container select. Let it have the simple make policy. Now in the parameters, what we want to do is that we want to set the production time per unit to 0.01. And we want to do it at a seconds. And then we define the production cost as 0.1 for each unit. And we can change the currency to GBP Great Britain currency. So similarly, we can create another for the same for the quick molds product, and we set the parameters to similar amount. Now we will create statistics to the dashboard. Add statistics to the dashboard. So we will click on the simulation experiment, and then in dashboard area we will go to here, and we can add an item. We will add the products menu. We will add how many production requests we get. So from the products menu we get the production requests. The products you produced and then the production units, production requests and the products produced. And we will toggle the per item basis. So each location we want to see and by each product we want to see. And then we add this item and then we can run in the simulation experiment. We run it in a virtual mode at maximum speed. So once this is completed, we can stop it and save the result. So in the production produced and request, we see that the that the disease have requested to produce around 24 million records for cake molds, and similarly the products produced in the factory for cake molds is the same amount. So we have completed now the phase. We defined the production policy and then adjusted the inventory policy. Now we would add raw materials and suppliers and then adjust the sourcing and inventory policy. So what we would do is we go to data and open the products table. And then we set the products as a plastic product. And we can set the cost to 1316. And the selling price set its selling price to 0 because it's a raw material. So we will pay 316 for 1 cubic meter of plastic. Now add another product and we will name it silicone. And we have again we will set it up 0 and then the cost will be 20 GBP. So what we have done is we have defined the raw materials that are required to manufacture our products. Now we'll define the unit conversion rules for these raw materials. These rules will be required since our experiment collects statistics in pieces. But the measurement of the raw materials are in cubic meters. So we will go to unit conversions table. And then we will add one product which will say as plastic. And then we'll say that how many pieces per 1 meter cube. So we'll say that we define 1 meter cube of plastic is equal to 1 piece of plastic. And then we add a silicone product as well. And similarly, we say that 1 meter cube of silicone is equal to 1 piece. Now we create a group of products. So we will see the product group table. And then we will click on add to create a new product group. And then we will name this as products. And then we will double click on the products column and then add the products that we want to add in this group. So we'll add these 2 raw materials in these product groups. Now double click and then we would want to add the 2 finished products in this product group. Now we'll go to suppliers. We'll add suppliers in this supply chain. So what we do is we click on add to create 2 supplier locations. One is for plastic supply and one is for the silicone supply. And then we'll define the locations for these 2 suppliers. So what we do is like we go to the locations table and then we scroll down to the bottom because we added 2 suppliers. So what we do is that in the city column of the plastic supplier, we can say Cardiff. So we'll say Cardiff over here. And then the silicone supplier, we are getting it from Gillingham. And then the country, we can say it is United Kingdom. And then we can toggle the local coordinates. So that the actual coordinates gets updated. Now, originally our supply chain didn't have any suppliers, so the factory was producing the products from the raw materials. The inventory policy was set that it was unlimited inventory to allow the factory to have as many raw materials in stock as required. The sourcing policy was not required to make any updates since the factory would always have the raw materials in stock. That is, no external sources would be necessary. But now, since we have added add suppliers, so we now go to the sourcing table to define the sourcing policy. Now, now we navigate to the sourcing table and we select the product column. We want to assign the newly created product group, which we named products, to this to sourcing lanes. Now we will create a new record in the sourcing table, and we daily select the delivery destination to factory, and then we select the product as plastic, Now we'll set the product to plastic, and then the sources is the plastic supplier. So we'll choose the plastic supplier as a source. Similarly, we'll add another column for factory for the silicon supplier. And we select the products as silicon and then silicon supplier. Now we'll update the inventory policy of the factory. The new policy will consider the raw materials that are ordered on demand from the factory. So what we do is we go to inventory table. So as the previous sourcing table, what we did is we will select the products group for the existing ones and then add to facilities. So we'll select it as factory and we'll set the product to plastic and the second one to silicon. And we'll set the policy type as to whenever the order on demand, whenever the order is received. So that's how. And then we have, so we can select the initial stock as 50 units. And then we would also update the shipping policy. So we'll go to the shipping table. And then we will click on add and then source. We will make as all suppliers and the destinations to all sites. Now we'll select the vehicle type. So we have completed by this step by adding the raw material suppliers and updated the sourcing and inventory policies. What we will do next is that we will define the bill of materials and update the production policy. So this will make the factory use the raw materials to produce the end products. So we go to the bill of materials table and then we add one row and name it as a container one. And then we select the end product as the food storage container. And then we set a quantity to be that 1712 items are required for making this. So now in the components, what we do is we will say that we will add a column and then we'll row and then we'll say that one plastic. So 1712 plastic required to create that particular container. Okay. And then for silicon, we will say that 0.023 quantities cubic meter of silicon is required to produce 1712 of container. So similarly, we would add the BOM for cake mold. So we'll name it as cake mold BOM, and then quantity we will set at 10,000. And then in clay components, we will say that one quantity of silicon is required to make those many thousand units of the product. So we have defined 10,000 units of cake molds. Now we need to tell the factory that the product should be produced according to the specific bill of materials. So now we go to production table. And then we will specify the food storage to container BOM, and then the cake molds to cake mold BOM. And then now we can run the experiment. So we need to specify 1 meter cube to pieces over here. And then run the experiment. So we see that the simulation experiment is running, and then we will run at the maximum speed. And then we save the result. We are interested now in the production of the end products based on the bill of materials that we have defined, which will define the expenditure of the raw materials. The factory now does not store any raw materials, so it has to request the raw materials by placing orders to the suppliers. Let's analyze the result by seeing if any orders are placed. So we will change the existing settings, and then we will now we'll open the demand placed by site and enable the factory here as well. And then we want to show the product per item as well. So we have two products, so that's why we want to choose the per item option. So here we can see that the number of orders placed by each facility. So we can see the factory has indeed has placed orders for these two amount. And it would be interesting to observe the factory's available inventory per item. So we can add a new page over here, and we can add the inventory. And we can see the factory only by each item. So we see that what is the amount it ordered and what is the amount it have available. So since it has these two types of finished products in its inventory, but it doesn't have any bill of material, so that's why it has placed an order. Now we can use also the fulfillment orders. So we will choose fulfillment of shipped orders. to observe the number of orders the suppliers have sent to the factory. So we see that the plastic supplier has indeed sent 86 orders of plastic and then 169 units of silicone.
This concludes the tutorial on simulation experiment using AnyLogistix. Thank you.